Hey guys, welcome back. House Prophet here. I hope you guys were able to see the famous and the legendary F-15. I mean, so amazing that these were fighters built in the 70s. One of the heaviest fighters, maximum takeoff weight plus 70,000 pounds, and one of the best thrust to weight ratio close to 1:1. So the engines could actually produce an equivalent 70,000 pounds of thrust, twin turbofans. Our bypass ratio is 1:1. Very, very unique aircraft. Still in service, by the way. Still looking for a replacement. It's an air superiority fighter, so it literally takes control over enemy airspace. Air superiority fighter means it's a combination of several roles. It's a fighter, and again, it's an intercept, and very, very expensive. We don't have so many air superiority fighters because of the expense, and obviously the avionics being expensive. So here, 737-700W, we got the winglets. So it's about 43 meters. For these aircraft, the fuselage width length is 1:10. Is 1:10, and guess what? For 787, you remember how many guys remember it was 195. So 737 literally is longer by fuselage width to length compared to 787. But 787 is a wide, so we are looking at making a wide body so that you have more people in a row than length. That's why this guy looks very long. It's only 43. That's the cockpit. That's the legendary, we call it the eyebrow. You know how the women do the eyebrow? They shave the eyebrow and then put this mascara. So it kind of looks like that. That's why I call it the eyebrow. And then you can see the basic design here is if this cockpit wasn't there, these two would blend. And this nose is roughly at 50% width. So that's how I do my approximation. It's about 50. That's your door, your windows. This one I just put them there so that you can see the balance of the aircraft. And this is my design signature nowadays. And then KQ. Right? KQ, anyone KQ in the house? For you guys, you can see that. And then the famous CFM56. So CF is continental US, and then for M is motor, which is actually French. So it's a American French. One of the best. Literally has never failed. Literally has never failed. But we have had several false starts, wet starts. Most of the time is a pilot error. So you can see how we try to blend. Those are the pylons, 6-point attachment pylons, flame arrestor. You can see the flaps, ailerons, and fairings. And then these are winglets, so these also a vortex diffuser. And you realize it has literally the same design as the vertical fin. So this and this take the same almost proportions ratios. So this span here, or the chord, and here, and this one almost the same. The only difference is because of this one has a dorsal fin. So when you add a dorsal fin, it's easier than making a large rudder, or let me call it vertical fin, not rudder, vertical fin. So these are lighter attachment, very effective. So increasing the root to tip chord ratios, and you're just making it more sweep. So if I make this more sweep, it just means it's going to be very effective at high angle of attack. So it will stall at a later angle of attack. So you can be able to deflect your rudder, especially when you have engine failure, VF, and you're trying to VMCG, control the aircraft ground, but also VMCA, control the aircraft airborne. And you see the Same thing, even the aileron takes that design where this chord for the aileron and at the tip and here they're not the same. This is larger, so it actually follows the same principle. This end should be larger than this, so you're not expecting that this length here, this chord here of the aileron, not aileron, sorry, about the rudder and here, they're not supposed to be the same. Okay. Another thing I want you to notice, for those guys who love what I do, and those guys also do the same, designers, you guys reach me out. You know, I can teach you a few tricks. We can also open up our own club for this. This is the future. This is the way Kenya we are moving. It's high time Kenya we step up. We need to, let's stop being called third world. We've got so many brilliant minds and still being called third world, even when it comes to aviation. I've seen a lot of brilliant people and we can do something. So I want you to notice something, that these aircraft, roughly at 70-80%, this is where we have the clearance. We have the launch of the clearance. Remember the last time I said between 13, so this angle from here, longitudinal up there, is about 15 to 13 degrees. For Dash 8, it's actually more compared to other aircraft. And also the Airbus, this would be probably 14, sometimes it can go to up to 15%. But 737, it doesn't really take a huge one. So that means this aircraft, I can already see it's geometrically limited. That means when it's taking off, we have a tendency of tail clearance. And here we have a 2-position tail skid. It's a 2-position here, it's supposed to be mounted, I didn't draw. And you see the horizontal there, nice, it's nice and sweet. What else from this aircraft? I'm just thinking brilliant, guys. So if you love this stuff, you love the presentation, and maybe next time on your comments, just tell me which aircraft I put for you and just tell you a bit of history of that aircraft. So anyway, guys, have a good evening, adios, and one more time, observe 737-700 Boeing. Look at that. Look at how everything has blended. So this is not artwork, this is design. There's very big difference, because these are actual angles. That angle there is measured. That's a launch of 20 degrees, this is a launch of 15, but I can also put it at 13. So that's 20. This one for this aircraft is 45 by 65 launch. So this angle here is 65 and this is 45. Okay, and then this launch and this, you can see they are parallel, so they have the same launch angle. So anyway, guys, have a good evening. Tomorrow, so you want to go back on 777, something I need to show you about the empennage. This is empennage. Now, fun enough, with this diagram, I started designing from here. So this was the first place I designed, and I can see it came out real nice. So this is actually evidence that the first aircraft built in the 50s, 60s, 70s were actually designed starting from the empennage. So we start designing from here, because also we need to see that clearance. Cockpit was a bit easier designing there, but this was where the issues were. So once we sort this out, the other thing to sort out would be now location of our engines. If you put a tail mounted here, it means the wings would move aft. So a good example is 727, DC-9s, MD-80s, all those aircraft. And also remembering the VC-10 4-engine turbofans. So you got 2 on this side and 2 on the other side. So anyway, guys, have a good evening, and I'll see you tomorrow. Adios, masalama, buenos días.